This is the last section of this chapter, and we're going to be looking at, remember how we talked about a finite population before? Well, it overestimates the standard error when sampling is without replacement. So what that means is when we determine a confidence interval with a finite population, meaning the population has boundaries, we have a value. We're given a value for the population size. Let me see if I can, okay. So here, remember we talked about if the sample size divided by the population size is greater than 0.05, meaning the sample is at least or is more than 5% of the population. If this is true, then we have to add this finite population correction factor to the formula the existing formula. So here it is for the confidence interval for when the population standard deviation is known. So see this part, the sample mean plus z times the standard error of the mean. All that we've done. Now when you're doing the confidence interval, if you have this finite population, you have to add that on to it. So it makes the formula a little bit longer. Same thing with the t-distribution. Remember we use a t-distribution when the population standard deviation is unknown. So if we need that finite correction factor, we will add it to the end and multiply it times r. Remember, this is your margin of error on these. So we're going to multiply our margin of error by that finite population correction factor. Okay, same thing with the proportion. You would put that at the end. Okay, so that is really the only difference here. Everything else you're going to work the same way. Let's just go ahead and take a look at question 1. Here we have a 90% confidence interval, and we want to estimate the population mean. Well, look at n and look at the sample size divided by the population size. N divided by n. So here 20 divided by 200 would be 1/10, which is 10%. Remember, if it's greater than 5%, then you have to use the finite correction factor. Okay, moving on. So we know we're going to have to use that, and we want to construct a 90% confidence interval for the population mean. And so we know that x bar is equal to 60, and the population standard deviation is known, so we can use z. If we didn't know it, we would use the t-distribution, and we know that n is 20. Uh-oh, I closed my whiteboard. Let me open it back up. We know that n is 20. The sample size is 20 and the population size is 200. All right, so we're going to go up here and get our formula. We are doing z. So here is the formula you would use since we know the population standard deviation. So let me make that a little bit bigger. There. All right, here we go. All right, so we need our z-score, and we need to calculate the margin of error. For this particular problem, it's a 90% confidence interval, And it looks like we're going to use technology to find our z-score. So remember 90%, 5 over here and 5 over here. So we need 95%, which is going to be 0.95 on our, actually 0.95. And we're going to do the inverse. So our z value is 1.644. All right. And I always like to look and just see, and you can always make a note, 1.645. So they did round to 3 decimal places for the z-score. Okay, so our z-score, we're just going to plug into our formula. We're going to do x bar, which is the sample mean, which is 60. And we're going to do plus and minus 1.645. And now we need to do the standard error of the mean, which you may have to go back and look, but it's the standard deviation divided by the square root of n. So here the standard deviation is 15, population standard deviation, divided by the square root of n. So n is 20. So 15 divided by the square root of 20 would give us, let's see what we're going to round to here. It looks like we're rounding to 4 decimal places for our standard error. So we're going to do 3.3541. This is a lot of work because you have an extra population correction factor to add on the end. So let's go to the side over here and get that. All right, so we get 200 minus 20 divided by 200 minus 1, and we're going to take the square root of that, and we get 0.9511 because we're still rounding to 4 decimal places. So you're going to plug both of those in, and we're going to round our interval to 2 decimal places. So that is, this is going to be your confidence interval, and this is the confidence interval for the mean of a finite population when the population standard deviation is known.